In this session in GroupBy, Bert Wagner is going to be talking about high-performance SSRS. So, Bert, take it away.
Great, thanks, Brent. Thank you for organizing all this again. This has been awesome all day. I've really enjoyed watching it all.
Thanks.
And I'm excited to present this high-performance SSRS. I mean, in summary, this is what we're dealing with in the presentation today. It's this. Hopefully, many of you are familiar with it. If you're not, maybe if you're on an older version, you're more familiar with that. But these guys here are our enemies, right? And so when talking about performance, if you're not familiar with these screens, these are the SSRS loading icon spinners that you see as you wait forever for a slow report to load. And the reason we want to focus on performance, I like to break it down just by, in terms of who your audience is, right? So for me as a developer, performance is huge because I want to build something that's going to work today, and I want to build something that's going to still work in the future. Otherwise, I want that technical debt of, as soon as we get more users or something like that, that the product breaks down and then I have to fix it again. That's not fun. From a DBA standpoint, I'm not a DBA, but I sure know DBAs who hate getting tickets cut saying that, CPU or memory usage is high, temp DB is filling up because you're doing all types of crazy sorting and other actions that you're not supposed to, right? So, part of performance tuning, will be that. And then, I guess most importantly, if you think the customer is always right, think about your users. And I'm sure many of us can sympathize with if we go to a website or something and it's taking too long to load, I have a tendency to just exit out of it. And, sometimes you can't if you need to, access something, but having to wait a long time really stinks. And I think earlier today, who was it at the Stack Overflow, was that
Greg,
yeah, I mean, he was talking about 10, 20 milliseconds. I mean, that's crazy. So full disclaimer, we're not going to get these reports down to 10 or 20 milliseconds, but we're going to do our best. So just brief background. So I'm a business intelligence developer, like I mentioned, at Progressive Insurance. I'm mostly familiar with 2008, 2012, SQL, SSRS. I'm more recently getting into 2016. Good news is I've tried all these examples out in all the different environments. They all work. Just the same, the concepts are the same, so it doesn't really matter what version you are on. The data we're going to be using today is actually the Stack Overflow data dump, which is from you, Brent, from your website there. I've linked to that in case you want to download it. I did also include scripts to actually reduce the size of the data because I think all uncompressed it's around 100 gigs and my laptop cannot spare that much space. So if you are like me on a small machine, you'll be able to use those scripts to kind of reduce the data a little bit as well. If anyone's not familiar with the Stack Overflow database, if you missed the presentation earlier, or if you've just never used Stack Overflow, right, it's a question-answer form. Essentially, users ask questions, other users, like probably many of you watching, respond to those questions as answers, and the best answers get voted on, and you gain reputation and points and things like that. So hopefully that'll make sense in the demos. And all the code, I've already posted it both on the GroupBy session website and on my personal website. So all the slides, the demos, the scripts that we're looking at, they're all on there. So you'll be able to download and play with those yourself. So just a brief look at what we're going to be talking about today. We'll start more generally at a high level, and then as we go through the presentation, we'll look at more specific use cases that I run into quite a bit. So there's some really interesting things there. Anything with an underline is going to be a demo, so we're going to be jumping around between Visual Studio, SQL Server Management Studio a lot today. And that's it, so let's just dive right in. So the very first thing I want to talk about is just SSRS usage data. So SSRS has data logging that it does for you, and this is important to be aware of because if you're trying to tune performance, you need a baseline. You need to know, what are you measuring? Are the changes you're doing improving the performance? Are they hurting it? And so the only way to know that is by taking a look at some of the statistics on how long the reports run. Fortunately for us, that's built into SSRS. In 2016, it's nice. There's a view that just shows you this relevant data. In older versions, sometimes there's an SSIS package you have to run to create the reporting structure for that data. But the key things, the key metrics we're going to look at today are these time retrievals. It's in the screenshot at the top of the screen there. So time data retrieval, that's just referring to how long it takes for the data to get from your data source. So in most cases, especially today, is SQL Server. How long it takes to get from the SQL Server to the reporting server. Time processing is taking a look at how long is your SSRS report processing that data. So if there's anything happening in the report where it's running expressions, or if it's sorting your data, aggregating your data, that's where all the time processing goes. That's how that gets counted. And then finally, time rendering is how long it takes to output that data onto your screen, whether it's via the HTML report viewer or if it's an Excel file, CSV, whatever you're outputting your data as. So with those three metrics, we'll be able to get a pretty good idea of how our reports run. Those by no means are the only metrics in this SSRS usage data. There's plenty others. I've included a link to the Microsoft site that kind of explains them all, but if you've never looked at them, there's some really good ones in there with memory usage and report size. So it's really nice to be able to go look and measure how poorly your reports are running. So we'll take a look at that table in just a second with our first example. I won't be going through the usage data for every single report because we would just run out of time, but feel free afterwards to go through this report, the demo reports, and take a look at that data for yourself and definitely use it in your own reporting environment. So briefly covered, and this is where I'm saying I'm probably in Gianluca's circle of hell sometimes. You'll see a select star in one of my queries. But we want to avoid doing that, and it's for the same reason Gianluca said. You're bringing back way more data than you need. If you're building a report that's only displaying 5 columns of data, and your table's got 40, and you're saying select star, that's a lot of extra data that's getting sent across the network, assuming you're on different servers. And you don't need that. Things like just performance on the SQL Server itself. Your indexing will suffer. You'll do more scanning because your tables are not built to bring back all the columns all the time. And then just from a more maintainability aspect, if you say select star and your table has 40 columns today, and in the future you add 5 more columns, there might be some things that break because you're now bringing back more columns than a report expected, right? And that's true of everything. It's not just reporting services. If you're writing queries for any other kind of applications, just don't use select star. It's a bad idea. Also, it doesn't really tell developers of intention. So if someone's inheriting this report from you later down the line, or even if you look at the report, 3 years down the road, you're not really helping yourself by not providing information, some context about what data is important and what you're selecting. Select star on its own, doesn't do a great job at explaining that. So we don't want to use it. That'll definitely help performance. All right, traffic and specialization. What this boils down to is using the right tool for the job. And so we'll jump into Visual Studio here in a second for the demo. But essentially, let's say, in this example, we're going to be creating a report to help us get better at answering questions on Stack Overflow. Like I said, if you answer questions, you build reputation points. So we want to be able to answer questions that are posted that don't have answers for them yet. So we're going to try to build a report of questions that we might be able to answer that don't have good answers yet so that we can get all the points. And so let's just go ahead and jump into the demo here. By the way, so here's my SSRS solution. All of the report names are prefixed with a number. Those correspond to the numbers in the slides. Pretty obvious, but I figured I'll mention it. So if we take a look at this report, and we'll run it in a second here, but let's look at the data set first. It's really basic. Select some columns from this post table. There's no filtering going on, nothing happening in the query. We're just doing our select from. And we'll take a look at another example of why maybe there's a better way of doing this. But our data set here, our filtering is actually happening in this filters section in the data set. And you can see we're filtering on things like accepted answer ID equals 0. So there's no accepted answer yet. answer count is less than or equal to 3, so there's not a lot of answers yet for the particular question. And in the tags, we're saying, okay, there should be a SQL Server tag, because that's what I'm familiar with. Those are the kinds of questions I want to answer. So by putting all this information here at the data set level, our query will run on the SQL Server, but then the filtering is going to happen in the data set in SSRS. We also, just for fun, since we want to sort the questions by timestamps, in my tablets properties here, I decided to do the sorting here in SSRS. And so some of you have used SSRS in the past and are familiar with this. If we go to run this now, you might already know what's going to happen. But if I run this report, you'll see it's there's our enemy, our loading icon. And this should take a little bit of time here, because what's happening is SQL Server is just running that basic select from. It's selecting, I think, 1 million rows of data from the table, moving it to the to the SSRS server, and then SSRS is actually filtering and sorting all that data based on those predicates that we provided. Now, SSRS is great at building reports. It's great at making it easy to build reports. I would argue there's no easier way of building reports as quickly and with such flexibility as SSRS, but it is not good at manipulating large amounts of data. That's not what it's built for. SSRS is built for reporting and displaying data. SQL Server, on the other hand, right, Relational Database Management System, is excellent at handling large amounts of data. It has plenty of efficiencies that are built into it to manage that data and to do those large operations like filtering 1 million rows of data down to only the ones that are relevant, especially using other things like indexes to help it perform even faster. So in this report, we're really not using any of those advantages that SQL Server offers us. We're just saying, select from, give me everything, give me 1 million rows from that table, and bring it back into SSRS, which will do the filtering and finally render our report. And so the report finally opened. I kind of killed some time by telling you what was happening, but if I was sitting there waiting, I'd be really bummed out about that performance. But if we actually go to the execution log view here, and we just run a query, I'm just filtering it on the last 10 minutes of data, because we don't need to see all the junk that was in there before. We'll see here's our report that ran, and our 3 columns of interest are right here. And so these are in milliseconds. So we could see, okay, it took 2.5 seconds about to get the data from our SQL Server to our SSRS server. So not too bad, I guess. But our time processing, right, this is where SSRS is filtering on those 3 predicates that we supplied. This is where SSRS is sorting the data. You know, that took over 20 seconds, took 22 seconds. And then to finally render the final report, it took, you know, another 5 seconds. So pretty slow. We could see most of our time is spent here in this time processing. That's in the SSRS server. By far, you know, in terms of performance for SSRS, this time processing column is where you can make the biggest impact, right? If you're smart about how you're designing your reports and building your reports, you can trim this down significantly, as we'll see shortly. And there's some other columns, like I mentioned, like what the report size, how many bytes it is, and how many rows. And this is interesting to note because this brought back all 1 million rows to the SSRS report before SSRS filtered it out. So not a great idea. Our alternative is we can have another report built. So this is part 2 here, where we use the right tool for the job, right? So if we open up this data set, same that we were doing before, it's still doing the same exact select from, but you'll see I've added the where and order by clauses here. So we're doing our filtering on these columns, you know, our accepted answer ID, our answer count, our tags. We're also, you know, ordering by its descending create date. That's all happening on the SQL Server. So before the data even gets sent to us in the SSRS server, all that data is going to be trimmed down. And I think there's only, you know, 4,000 questions that get brought back. So, you know, 4,000 rows of data coming back to SSRS is much faster, as we'll see in a second, than bringing back 1 million rows. You can see I took out from the filters here. There's no more filtering of the data set in SSRS because that's what SSRS is really bad at. I've also removed the sorting from the tablets. So if we go back to our report server, and we take a look here. Let's open this guy. Still a loading screen. If I have access to the SQL Server, I could obviously add some indexes. I didn't for this demo, but it could obviously be way faster. But just by removing all that processing from SSRS, you can see this came back significantly faster. Same number of results and everything. If we jump to our usage data table, we'll now see another row. So if we look at this top entry here for comparison, so our SQL query took a little bit longer, right? It was no longer just doing a select from. There were some where statements it had to process. It took about 5 seconds. But our time processing in SSRS, right, is a quarter of a second, basically, significantly faster. And the time rendering significantly faster as well. And you could see, even though the report size is about the same, the row count is drastically slower, right? So there's way less rows going to the SSRS server. So the moral of this story is just don't use the wrong tool for the job. Use the right tool for the job. In this case, SSRS is great for displaying data, and SQL Server is great for processing it and doing all the heavy lifting. All right, multi-value parameters. So there's a few different ways you can handle multi-value parameters in SSRS, and there's good ways and bad ways once again. And I just want to go over those different ways because they all have their pros and cons, and multi-value parameters are something that I use a lot of in my SSRS reports. So if we go ahead and jump back here, we'll open up this report. So you could see, let's just preview this in here. And so when you preview it in here, this doesn't capture the usage statistics, but from going forward, we won't be checking back to that table every single time. This report, pretty basic. We have some post types that are coming back from the Stack Overflow database, and this is a multi-value parameter. If we just select some more, this report will show same data. It's just showing us what got filtered from those parameters. And each column here in the report is showing a different method of getting that data. So if we go and look at how the report is actually designed, we'll see we have some data sets. This first one is just for the parameter, the drop-down parameter, to get those values from the database. So we don't have to take time to look at that. But our first column here is filtering that data using an expression filter, right? And so this will look a little bit familiar to the last demo, where we're doing a select from our post types table here. And instead of filtering here at the dataset level, we're actually doing it here on the tablets, which to my knowledge, it doesn't make a huge difference. They're both just bad. You don't typically want to do them, but here's our expression of saying, okay, let's filter our ID column on this, whatever the parameters that are passed in from the top of the report. In this case, you saw when we ran the report, it ran fine, it ran fast. I still would rather people didn't do it this way, but there are some advantages where if you want to use certain expressions to do certain things to that data, it's a little bit more flexible to filter this way. But if you're bringing in more than 10 rows, it's something to really reconsider. Is this what you really want to do? Because performance is really bad, as we saw in the last demo. So the second method is the query text method. So if we open up this data set and we take a look at the query text window here, same query, select from, but now we have a where we're filtering on our parameters from our multi-value parameter dropdown. So cool, we took the concept that we learned in the last demo and we're doing all the heavy lifting on the SQL Server.
Kenneth asks a good question. He says, when is it appropriate to have SSRS do the filtering itself instead of passing it to the database?
It's really oddball cases. 99.9% of the time I'd say it's not worth it. If there's certain things you want to do, maybe with expressions, like if you dive into the tablets, there are some things that you might be able to do a little bit easier if you're getting to have all the data available to you. It depends. Sometimes you'll be constrained with, I guess it depends on your environment. If you are constrained by what you are able to do in your SQL Server, then SSRS might be a place to do it, but really, you shouldn't do it. it's not efficient at all.
George has one. He must have a bad or a particular environment. He says, George says, only when the data set is derived from a stored procedure and the BI dev can't touch the stored proc. So it sounds like he feels that particular pain.
Yeah, I mean, it happens ideally, right? I mean, that's a great example. If you can't modify the stored procedure and you're stuck with the data coming back, then, I mean, not much you can do.
In Slack, Andy Mallon adds one. He says a shared data set with cached results is a great scenario for filters on the reports. Oh, okay, that makes sense.
Cool, great. So method 2 then, if we just jump back to that, right, was the query in the query text editor. So this is great. Our heavy lifting, so to speak, is being done on the SQL Server, so it should run much faster, as we saw in the previous example. But it kind of stinks that you're using this query editor window here. I hate this thing. I'm sure many people do too. It's because it kills your formatting. If you want to add comments, if you want to format your queries, it's super ugly. You know, you can format it. You could spend all the time in the world formatting your queries in Management Studio and paste it in here, and then, you know, after some point, it's just going to look like garbage again. So, from just a maintainability standpoint, I really hate using this window in here. But I also have to say sometimes I'm really lazy, and it's just really easy if you know a query is quick and easy and simple, it's much easier just to write your select statement in here and go with it and pretend that you'll refactor it later and change it to a stored procedure. But that's not a good practice. That belongs in the previous presentation of worst practices. The last data set here is using our stored procedure. And this is doing the same thing as before, the same query, but now we've put in a stored procedure. So we're going to get lots of benefits where in the future we might have some flexibility in terms of you know, what we want to add to that procedure. If we want to add commenting and different things like that, it's much easier to do in the stored procedure. If we want to, for example, reuse a stored procedure, if we have a data set that we want to use on a couple different reports, it's much easier to centralize that code in a stored procedure than have to copy and paste a query from data set to data set among reports. So it's definitely the best option. A little bit more work because you have to do the very laborious task of going to Management Studio and writing create procedure as, but you know, definitely what you want to strive for. So if we hop back here. All right, parameter sniffing. So once again, since there are so many parameters that get used in SSRS reports, multi-value parameters, I experience parameter sniffing a lot. And I know parameter sniffing is a topic that has had, you know, lots of coverage in other people's presentations. I mean, people do whole presentations on parameter sniffing, so we're just going to do a very brief overview of it in case someone's never heard of it before. But you basically, you probably have a parameter sniffing problem if you are running a report and it runs for you in, you know, 5 seconds and it runs great, and then someone else is running that report and you get an email from them saying, hey, why is this taking 5 minutes to run? You know, that could be a sign that you are dealing with a parameter sniffing issue. Basically, what parameter sniffing is that SQL Server, SQL query engine tries to cache query plans, or it does cache query plans the first time that they run. And so if you have a parameter, it'll cache a query plan for the first value that was ever passed into that stored procedure. Or query, it doesn't have to just be stored procedure, but if we're using stored procedures like we should, then it'll be a stored procedure. And what then happens is if a different parameter value gets passed in the future, that same initial query plan is what's going to get ran, even though that query plan might not be optimal for this new parameter value that we're using. And so there's a couple ways to fix it. We won't go through every single possible way out there because I don't know them all. There's so many, but at least this will give people an idea of how to deal with this problem, how to recognize this problem, and how to deal with it. So if we look at this demo script, I've included the execution plan here, the actual execution plan. And in this case, let's say we're going to be planning a conference in the future, and we're going to use Stack Overflow user locations to determine, you know, where's a big user group of where we want to hold a physical conference. right? So I have two queries here, really basic. They're doing the same exact thing. They're pulling from the users table where location equals something. In my first query, it's looking at users that have China set as their location, and the second query is looking where users have India set as their location. So if we run this, we see for our China result set, we have 383 rows, and for our India result set, we have 3,000. So a whole order of magnitude larger. In that India value, all the rows make up a much more significant portion of the table. But if we look at the execution plans for both of these queries, we'll see that for the India query, for the China query, the SQL Server is doing an index seek with key lookup, and for the India query, it's deciding, okay, since it's a much bigger portion of the table, we're going to use a clustered index scan to bring back that data. It'll be more efficient. So these are kind of what we are now going to refer to as the most efficient execution plans for these queries, or at least what SQL thinks off the bat. Now, if we parameterize this query, as you see here, and we'll run China and India again, we'll see we get the same exact result sets, right? Nothing changes, but since we're now using this location parameter, parameter sniffing kicks in. And we see that for both of these parameters, for both the China and India queries, they're both now doing index seeks, even though we know from above that the India query is better off doing a clustered index scan. But because this China query ran first right now, SQL cached the plan and it cached it as index seek. So, and if we put this in a stored procedure, the it doesn't matter if you're using a query or a stored procedure. Nothing is immune. So here we have, once again, right, index seeks for both. But now if we clear out the query plans, and obviously don't run any of this stuff in production, especially from now going forward, we're going to start doing some stuff that could make your DBAs really unhappy, or if you are a DBA, I guess it'll still make you really unhappy. But if we get rid of all the query plans and now we run the India parameter first, we'll see that, or at least we should see, never can be sure with a live demo, that the clustered index plan is what got brought back. So since we ran the India parameter this time, the clustered index scan is what got cached by the query engine, and so when we ran the China query below, it's also using the clustered index scan, even though we know that that is not the most efficient plan for that parameter. So what can we do about this? This is just a few things to maybe start out with. Not an exhaustive list by any means, and there are lots of caveats with using all these. So let's start with the first one that I see a lot is just, let's throw with recompile on everything. Right, fixes the problem. Great, awesome, there we go. We got our efficient execution plans once again, our index seek for China and our clustered index scan for India. The problem is with recompile forces the query engine to try to determine the best, or I guess to rerun and determine the optimal execution plan every single time, which determining that execution plan is a really expensive process. So that's why it gets cached in the first place, is so that SQL Server doesn't have to constantly do it every single time. With recompile, you lose all those savings, and SQL's having to rerun that expensive operation to calculate execution plans. So even though it may look like you are getting the more efficient plan here, you are not using the benefits of the server's caching capabilities for these plans. So another option, though, to be aware of is basically this option recompile statement in here. So this does the same thing as the with recompile outside of the query of the execute statement, but if we put it inside the stored procedure, it's more centralized. So if we're calling this stored procedure from all over the place, it's a shared stored procedure used in many different reports. This is an easier way of fixing it in one place and having the fix be applied everywhere. Fix, once again, meaning that you are losing all ability for SQL to cache those execution plans, and it's having to recalculate them every single time. A third option, which I think is slightly better, is using this optimize for hint. And if we alter our stored procedure to that, what this optimize for does is it says we're going to create the execution plan and we're going to cache it. We're going to cache it for the value that we pass in as the parameter here as part of this hint. And so in this case, I've passed China in, which if you remember, that's the index seek query plan. So if we run this, even though India is being ran first, we'll see we have both of our index seeks query plans. And and the way I made this decision is I tried a bunch of different values in here, did some research. At the top of this query document, I put the I turned statistics for time and I/O on, and I did some research and I figured even though this index seek query plan isn't the most efficient for India, for the India value, it is way more efficient than trying to do a clustered index scan for those 300 rows for China. So I decided that that was the best option in this case, and you can do lots of different things. Like if you know most of your results that are going to come back are, let's say, around 10 rows, and then there's one parameter that brings back 100 rows and has a different execution plan, you can optimize for a parameter that you're going to hit the majority of the time. So at least you're benefiting from SQL's caching of that execution plan without and only compromising when you're passing in that occasional variable that is going to get a less efficient, less than optimal execution plan. So that's another great way. There's a lot of other options out there too. You could use if-then statements in your SQL queries to call different stored procedures. With each stored procedure kind of optimizing for different parameter values, and you can set your incoming parameters as local variables, and that'll accomplish similar things. So there's, like I said, people have done whole sessions on parameter sniffing. If it's a problem you are having, hopefully now you'll be able to recognize it, and for sure do your research and test out different solutions before you implement any of them. But if you can fix that, your reports will definitely perform better. All right, so explicitly defining property values. In all of our SSRS reports, if we look at one of these, anytime we click on a text box or anything like that, we have all these properties down here. And there's a lot of these that are like can grow, can shrink. If you're dealing with images, there's like image auto size. If you want ultimate performance, you should not be using those auto properties. You should set explicit values. Basically, any property that needs to be determined at runtime is costing the SSRS server. It's causing the SSRS server to perform additional calculations. So if you can, let's say, specify an image width of 500 pixels, that's one less thing the reporting engine needs to figure out while it's trying to display the report on a user's screen. If you know your text box can be limited to a certain size, you don't need to, you can set that and don't allow it to auto-grow or auto-shrink, and that's one less decision, one less step that the reporting engine has to do when it's trying to render that report to the user's screen. So, setting these properties here, I included a link to Microsoft's website where they go through many of these properties, maybe all of the properties, and what their effects are on rendering time. But this isn't going to save you minutes of time. But if you're running a report that's running thousands of times a day by hundreds of users, thousands of users, every second counts. And if you can eliminate a second or two, if you could shave that off your report time, your server is going to be under much less load because of it. So this is where we start to get into really fun processes. So stored procedure CRUD operations. CRUD stands for create, read, update, delete. Most people think SSRS can only render data to the screen, and that makes sense. It's a reporting tool. It's meant for reporting on data. But there are many instances where getting some kind of user feedback, some user input would be very beneficial, especially from a performance standpoint. For example, if you have users who are different user groups who are using the same report, they might be using that report in different ways. You know, user group A might always want the data sorted a certain way. User group B might not even care about one of the subreports that are part of your report because they never use that data. You know, user C might be doing something else, but you know, for maintainability, you just have one report and you have all these different user groups using that report. It'd be nice if you could, you know, have some user preferences. And if you don't have access to creating some other way to get input data from users, like SharePoint or InfoPath, or building, you know, a website to capture that data, then all you're left with is reporting services. And good news is, though, you can capture input data. And so we'll take a look at that now. And for this example, whoops, let's actually start with the final product, because I think it'll make a little bit more sense here. So in this example, what I'm doing is I'm saying, okay, from Stack Overflow, I have some favorite posts. I created a favorites table in my database, and I'm just basically storing the post IDs for whatever post I mark as a favorite. So you can see I've marked some SSRS related posts as favorites. I have the option to unfavorite them if I want to. I also have just another query running down here that is showing related posts, and you know, they're SSRS posts as well. Maybe I want to favorite them. So let's try that. If I have this post ID here, so it's 653, and I press the favorite button, it'll actually go, and behind the scenes it is inserting that post ID into a table. You can see there it is 653, and now my query, which is querying from that favorites table, is pulling in that new entry because I marked it as a favorite. If, let's say, I accidentally did that, I don't actually like that post, I can click unfavorite. And behind the scenes, SQL just deleted that entry from my favorites table, and so now it no longer appears as a favorite. So how do we do that? You know, a lot of people I talk to, they have no idea that you can do this with SSRS. And admittedly, I don't know if this is an intended feature or not, but it is possible, and it has been possible for many versions. And you know, if you're really desperate, this is by no means should you use this as your first preference. Like I said, SharePoint, InfoPath, websites, definitely much better. But if you are stuck, like I have been in the past, then this may be viable. So if we take a look at what this report looks like here. There's a couple key things to be aware of, and the first is, let's look at our data. The first thing to be aware of here is that our data sets, some of them have columns. So our favorite post data set, which is returning our list of favorite posts here, has columns that we're loading into our tablets, and our related post as well has columns that we're loading into our tablets. We'll see we have two data sets here which are not returning any columns at all. And those are stored procedures. So the set unfavorite stored procedure is deleting from our database, and the set favorite stored procedure is inserting into our database. And the key thing to know with SSRS is that as long as the data set has all of its parameter values set, and in case of data sets that don't have any parameter values, those data sets will always run. So data sets in SSRS will always execute. And that's really important too, just as a side note. If you have data sets in SSRS that maybe you created them because you were going to use them in a report and then you're not using them at all, get rid of them, because every time someone is opening your report, that data set is running unnecessarily because you're not doing anything with that data. So get rid of unused data sets. Data sets always execute as long as all their parameter values have been filled. The second key thing to be aware of is in our data source, if we open up these properties, there's this checkbox down here called Use Single Transaction when processing the queries. By default, this is always off, and I highly recommend that that stays that way most of the time, because what that does is when that box is not checked, your data sets will, if they are able to, execute in parallel, bringing your data back faster. When we check this box, the data sets execute in sequence, and so in this particular case, that is exactly what we want to do. We don't want the data sets here running in parallel. You'll see why in a second. We want them to run in sequence. And the order here of these data sets does matter. By the way, there's no way to change the order of these data sets, which is very frustrating, at least in the GUI. So the way to do that, in case no one's ever done it, is if you actually right-click on your report and go to View Code, you can find the names of your data sets here, and if you just reorder the XML code and then reopen your report, it will reorder the order of the data sets. But yeah, not very fun to do there. So moving on to the body of the report now, if we take a look at these links that I created, if we go to the properties and we look at the actions on them, you can see when we click on the link, we're just going to reload this report, right? We're not doing anything else. We're just going to run this report again, but we're passing in a couple parameters. And the first one is the post ID from the row. So, right, if we're looking at the report here, there's going to be multiple rows. Let's pass the post ID of the row that we clicked, so we know which post to unfavorite in this case. The other thing we're passing is this action string, and so in here, the value just in here is delete. You'll see why that's important in a minute, but it is we are telling that this is the delete action, and then similarly in the favorites link here, if we go to the action section, we look at the what's in here. We're running the same report, passing the post ID, but our action here is insert. Since we're going to mark something as a favorite, we're going to insert a post ID into a table. And so if we go look at our scripts for all of this, you can see here's our favorites table, super basic. If we look at the data in it, there are 2 posts in there. Here are our stored procedures. Our select users favorites, right? Those are your favorite posts. They're just basic select query here, joining on our favorites table that we created with the actual post table from Stack Overflow, and we're limiting it to our user ID that's being passed in. So, these are my favorite posts. If Brent went to this report and he did, marked his favorites, he would have his own favorite posts, and that's where these preferences can then make reports run faster, because now you have additional data for you to be able to write more efficient queries with based on the particular user who is accessing the site. Now and then this is the related post query. Once again, nothing really special here. I just hard-coded some related posts. It's not doing any kind of magical technique of looking at post tags or anything like that. The interesting stored procedures are our insert and delete ones. So you'll see our insert it's getting 3 parameters passed in: user ID, post ID, action, and then it's running an insert statement, which is basic too. The key thing here is that action, which if you remember, that's the parameter that we had on those links, on either the favorite or unfavorite links, and it's checking to see, okay, let's only run this insert if the insert is the value of our action parameter. Likewise, for the deleted post stored procedure, we're only going to delete it if the action that's passed in is the delete. And so we finally have all of our pieces put together here to kind of explain what's happening. So when we click favorite, this report reloads, and since our data sets are running sequentially, we first run this set unfavorite stored procedure, but since our action for our favorite link, it says insert, nothing happens with this set unfavorite stored procedure. It hits that if condition, it doesn't come back as true, so it doesn't do any deleting. On our set favorite, it runs that stored procedure, and since the action parameter in our favorite link is insert, we insert that row into the database.
That's really
and then,
cool.
Since we've now either inserted or deleted the data, depending on which one we clicked, we rerun our queries for our favorite posts and related posts. If we added something, it gets displayed properly on screen, right? And so a lot of people don't believe me, but if we look at, if we run the select statement, so we only have 2 IDs in here, 2 rows. If we now run this favorite button and we go back then to the database and rerun our query, we could see that truly did. I'm not, faking it or anything like that. It is truly inserting into the database. And so, yeah, I mean, you could do inserts, updates, deletes. You could really do anything on the SQL Server that you can do from a stored procedure. So not just preference screens, but you can save other data, additional user history, parameters that they run in a report, even though the SSRS usage data has that by default. Those parameters are concatenated together with, I forget what, ampersands or something, so it doesn't make it very easy to search. So if for whatever reason you needed better logging, you could implement that yourself. If you're if you need to run some kind of queries, not regularly, not to the point where you can schedule them, but you could create a dashboard with a bunch of links that will allow you to run queries when you manually need to in a very easy way. So
I love it. I love it. It makes me that makes me want to write reports. That's awesome.
there you go. So I mean, once you learn, so it's obviously it's a little complex to set up. There's a lot of things that can go wrong, so definitely test. But if you need to capture user input, you could definitely do it, and that's the way to do it. So we use that a lot where I work. It's awesome. It's great, and it's really fun to build those reports too. All right, dynamic SQL. So
several people have asked questions. I'll just hit Ann. Ann says, could you do it? Have you ever done it with one stored procedure for both cases instead of breaking it up into two stored procedures?
Yeah. So there's a lot of different ways you can do it. There's, and in terms of needing like an action parameter, there's really multiple variations on accomplishing the same thing. I just kind of chose what I thought would be easiest to understand in this demo for the largest number of people. The key thing to remember, though, is just check that box saying the data sets are going to run in sequence, and inside your data sets, then order them in the correct order so that if they're running like in a sequential process like in an ETL, your final results will look like you intend them. But yeah, there's definitely more than one way of doing it.
Then Faig says there's a nice stored procedure from Pavel Pawlowski to generate 4 CRUD procedures for a table. We use that as a starting point to expand tools to 13 different kinds of objects. Holy mackerel! Wow. I'm guessing that's complex.
Yeah, that sounds interesting.
Yeah.
Okay, so the next level of SQL hell here, or dynamic SQL for performance. Yes, so before we even talk about this, I know dynamic SQL has a very bad rap, and rightfully so. There's a lot of stupid things you can do in it. There's a lot of bad code you could write. There's a lot of from a security standpoint, there's you have SQL injection, and there's a lot of problems that you can run into. But if we're talking about writing the most efficient reports possible, then dynamic SQL can help us in certain scenarios. For example, let's go look at a report here. And so in this report, what I'm doing is I have a list of users from Stack Overflow. So let's just select a few of them. And we're getting kind of like a baseball card stats sheet on them, right? So in the columns running across the top, we have each user, and we want to see different attributes. So we have years of wisdom. I couldn't bring myself to write age there. And we have, when they last accessed the site, and when, how many upvotes, downvotes they have, what the reputation is, and then we have some coloring going on for the, max value if you're looking across all our different users. Right, so this is an easy way to kind of compare user statistics on different users. And now if we select, additional users, like there, this report gets wider. Come on, let's select some more so we get some better colors. There we go, right? Report gets really wide, but as humans, it's much easier for us to visually compare data side by side like this than it is if we were to store it, vertically. It'd be really hard to jump around from one user and then skip, 5 rows of attributes down to the next user to compare who has the bigger reputation score. So even though in our database, storing data that's maybe more normalized or more vertical is easier for us to write queries on, in the end, if we're building these reports for users, we need to do what's best for the user. And in this case, building these kinds of really wide, dynamically width tables in SSRS is very painful, unless you do it with dynamic SQL. And in order to get really great performance, the only way to do it is with dynamic SQL. And so let's go take a look at why, because there's a few elements here in action together. So, okay, here's our report. You can see our tablix is super basic. On the page, it's just this labeled, C0, C1, C2. Here's our parameter query for our drop-down menu. So that's just getting a list of users. And here's our data set, which is bringing back our users. So the only caveat here is you need to know what the maximum number of columns that you will get back is. So in this case, I limited my user parameter query to 30 users, so I added 30 data columns to my data set. You can see in here, all this is doing is calling this stored procedure. So if we go look at that stored procedure, here it is. This is definitely not a tutorial on dynamic SQL. We're going to briefly go over this, but the idea with dynamic SQL, in case you've never used it before, is you are programmatically building a query string, and that allows you to do lots of fun stuff that you can't just do with regular SQL syntax. And in this case, building a table like this, I mean, we could have used pivots, unpivots, but eventually to make the width the way we need to, you still need to add dynamic SQL to it because you won't know the maximum, or the maximum could change. So all of this here is we're gathering our data, we're building up our different variables where we're storing query strings, and then we're finally putting all our query strings together. Once again, I can't stress, don't let user input parameters and values come into here without you checking them or sanitizing them, or yeah, you're going to have some serious problems when someone drops a table on your database. But anyway, that's our stored procedure. If we actually just look at the output here, right? So this is the data that's coming back for these 4 user IDs that I have here. We have 2 columns here, which are interesting. We have a column count column, which this is telling us how many of these C number columns we have, right? So 4 users, sorry, 1, 2, 3, 4. Our C0 column is our different attributes or properties for each of these users, their stats, I guess. And then we also calculate their max value here, and we put that in a column. And so, there's a couple things going on here. One, you can kind of tell we are formatting our data in SQL Server. This kind of goes against, my very first slide or second slide back there, right? SQL Server shouldn't be used for formatting, displaying data, but in this case, if we want an ultimate performance, this is what you have to do. You start formatting your data to the point where we're just going to put it into SSRS and drop it in there. So SSRS just has to display it. It doesn't have to do any kind of monkeying around to get the data into this format. And so that's why we kind of have, our column names in the first row and our column and our row attributes in here. Another thing that we do, right, is this max value column. So if you remember in the report, we highlight some of the cells green to indicate which ones had the highest value for vote counts and things like that. And so SQL Server, especially on larger data sets, when you get out of the demo realm and into the real world of data, calculating aggregate functions is much faster in SQL Server than it is in SSRS. So we can pre-calculate what the max values are and store them in this column, and then use those to color the correct cells green. So then, if this is our stored procedure, right, so if we add more parameters to it, we'll see that it is bringing back a wider result set. So then if we hop back over to SSRS, we have once again, our data set with the max number of columns defined, and we have our tablix. So our tablix also has all of the columns of data inputted into it, which is a little tedious, which once again, I hate doing tedious things, but for performance you have to do it. An easier way of maybe building tables like this, because 30 isn't too bad, but if you have to do 100 or something, it gets really bad, is just go into the XML view, right? Go in here, you can copy and paste fields, like if we go find, these are the fields of our data set, but here are our tablix columns, and somewhere in here, right, you'll be able to find, so here we have some expressions which we'll get to. So you can find the fields in there and you can copy and paste the fields to make the job of creating so many columns a little easier. Once you do that, the last thing we have to do, or the 2 last things we have to do, is, let's say we're bringing back only 1 user of data. We don't want to show these other 29 columns on our page. So on each of these columns, this is the one little bit of SSRS inefficiency that we're doing, is we're going to the column visibility for that column, and we have an expression here, in which it says, so if we only have 1 column of user, so only 1 user was selected, we have that column count field, which is coming from our stored procedure. And we're saying, okay, let's show this column if there's at least one user. Otherwise, let's hide that column, which, by the way, this is another huge pet peeve of mine. I hate that this is set expression for hidden. My mind doesn't work that way. It doesn't work in double negatives. I always want this to be set expression for show, but I always reverse these two. But the point here is we're hiding the columns that are unused, right? We don't want the user seeing empty table cells because there's no data coming back. So you have to go through and add this expression to every single column, which once again gets very tedious. We're doing this in the name of performance, and to help you out, I just recommend going on the back end of the XML code and copying and pasting. It's a lot easier. And finally, to get our green colors working, instead of having to calculate maxes and things like that in SSRS itself, we can just, on our cell where we want to change the color, we can see we have an expression here for the background color. If we open that up, you'll see all it's doing is it's checking that max value column coming back from our data set to see if the current value of the cell column matches whatever the max was that was calculated in SQL. Right? Much simpler operation, and if it's true, then it's changing the color to green. Otherwise, it's keeping it white. And so that then that final result is this nice table which adds dynamically as many columns as you want, and colors the backgrounds without having to do any kinds of heavy calculations in SQL, in SSRS. So once again, even though this is dynamic SQL, not a best practice by any means, but in terms of performance, if you need to get the ultimate performance, there is no faster way of doing this than formatting and preparing your data as much as possible in SQL Server, and then letting SSRS just display the data as simply as possible, as it's doing in this case. Now, we just have one demo left, and so we're doing good on time here. So, like I mentioned, the performance, the one downside of that report was adding all of the visibility expressions to those columns, right? Because if you're bringing back one column of data and you're having to hide 29 other columns, that takes some time in SSRS to process that. So one solution to that is subreport switching. So if you know that you're going to have variable numbers of expressions, you can use multiple subreports to kind of lessen the burden on SSRS. So let's take a look at that. If we open up this example, well, so if we look at let's look at the finished product first, right? The finished product is exactly the same as our previous example, but if you run performance statistics on it, you will see that this one runs much faster. And the reason for that is because we are using multiple subreports to divvy out how many expressions we want to run. So if we take a look at this report here, you'll see that we have a subreport switching parent report. So we'll open that first. Let me close all my other windows here. We have this subreport switching parent report, and we have 3 child reports. So child 1, child 2, and child 3. And so our parent, as you can see, has a subreport here, but we only see one subreport. That's because all of the subreports are stacked on top of each other. It's like, that's our little secret about this. We take all the subreports, we put them one on top of another, even though there's 3 individual reports. And so what we're looking at here, this report just captures the user parameter, and it sends that data to one of these subreports. And each of the child subreports, the only thing that's different about them, right, is they're all running our dynamic stored procedure, but child report 1 has only 5 columns defined. Child report 2 has 10 columns, and then child report 3 has all 30. Right? And you can divide these reports up however many times you want. You don't need 3 of them. You could have 2 of them. You could have 20 of them. With 20, though, I hope you have lots of patience or need for that kind of performance. But what this accomplishes is that if we get a report where a user only selects 3 Stack Overflow users to compare, we're going to run this subreport here. So it's going to fill up these columns 1, 2, 3 with data, And then an expression is only going to have to run on columns 4 and 5, right? So hiding 2 columns in a tablix is much faster than having to hide, 27 columns if we ran, our original report here that has 30 of them. And so that's what we're basically doing. We're sending the data to the report that is best equipped to display the data with the least amount of additional, expression running as possible. And so a couple key things to know about that is the way we want to do that is if we look at these subreport properties and we go, first thing is the visibility, right? If we don't do anything with the visibility, all these subreports are going to show up on the screen all the time. So what we want to do is if we're looking at the visibility for child 1, which can handle 5 users, we check the visibility expression and we say, oh, okay, if there are more than 5 users, we're going to hide this subreport. Drives me nuts. Versus false, right? So if there's 5 or less, we're not going to hide this report. We're going to show it. And then so the other 2 subreports have similar visibility expressions, right? So for this child 2, which if you remember has 10 columns in it, and here's our great nested if there's more than 10, we're going to hide, but if there's more than 5 columns, we're not going to hide it. This definitely took me a couple tries here to make sure it was working the right way. I was messing with my mind. But yeah, what's happening there is only the subreport is showing for the one that can handle all of the data you need. Now, the only other thing you need to do is even if you set those visibility options, all 3 subreports still run all the time, which is really defeating the purpose of this, where we're trying to gain efficiency by only running one of the reports, and in particular running the one report which minimizes the number of visibility expressions that we need to run. So in order to prevent that, on each of these subreports, in addition to the visibility, we have a parameter here that we're passing. We're passing our parameter, our user drop-down value parameter, but we have an expression on it. And this expression is, well, here, let me choose a simpler one. Pick the hardest one. If we go look at that expression, so this is the expression for the child 1 subreport, which only has 5 columns. We're saying only send our user parameter if there are less than 6 users selected, right? So if there's less than 6 users selected, send our user parameter to it. Otherwise, don't send anything as that parameter. And what that does is, like a few slides ago when we were talking about the CRUD operations, I was saying every data set always runs except, if one of the parameter values for that data set hasn't been set. And so by sending nothing, our data sets in our subreports, right, let's take a look at one of those. Each of these data sets, rather, the parameter here gets set by default by its parent report, right? We don't have any available, no default values. So then if our data set in here is requiring a parameter value of a user, but we don't send it from the parent report, then this subreport will still run, but the data set doesn't execute, which means the report will not render, which essentially accomplishes our goal of not, displaying the data, not rendering that data if it's not necessary. So, the key thing to remember if you decide to split up your data this way is, make sure you set that visibility expression on each of these subreports so only one of them shows at a time. But additionally, and even more importantly, I think, is make sure you pass nothing as a parameter value to the reports that you don't want to run. Otherwise, all 3 of your child reports, subreports, are going to execute, and you're really losing any kind of performance benefit that you did by creating all these subreports in the first place. So divvying up the work in subreports like that is a really great way to reduce the amount of time SSRS needs to be running expressions unnecessarily.
Yeah, Carnegie's excited about that in the Slack room. He likes that a lot.
Oh, great. Glad to hear it. And so, that's it. Thank you, everybody, so much. I appreciate you listening in. I hope you learned some cool new tricks that you can use. Please go to my session website there in the GroupBy link. Rate the session. I love feedback. Also, the presentation, slides, demos, everything are linked there. They're on my website. You can go there. If you have any questions, you can email me, send me something on Twitter. I'm happy to answer them. So once again, thank you, and thank you, Brent.
Oh, my pleasure. No, thanks for presenting. It's been fantastic. And several people are commenting in. James says, good stuff. Kathy says, very clever tips. JD says, this is pretty awesome. George says, yeah, you did such a good job for a young guy. I'm like, whoa, okay, all right. Ann says, terrific session, extremely well planned and cleanly presented. Vincent asks, what's your favorite new feature of SSRS 2016?
Oh man, so he's got me there. I haven't used 2016 outside of my regular laptop. There are some interesting features I know with like mobile that I want to play around with a little bit more to see how those work. But in all honesty, I haven't used SSRS 2016 to its full potential yet.
Mm-hmm. Chitan says, I wish my SSRS developers saw this. Well, it'll be on YouTube too, so watch groupby.org and we'll have it up in like a week or two. Lee says, in a reporting environment, is using with recompile really all that painful? And I'm guessing he means if his reports only run once a minute, twice a minute.
Yeah, I mean, it definitely depends on your usage. If you have reports that run a couple times a day, you're probably not going to feel much pain, which is why then that might be a great option for you. If you have a report that's running way more frequently with many different values, with recompile might not be the best choice. So it depends, that famous SQL answer, right?
Yeah, right. All right, well, thanks a lot for presenting here today. Folks, we're going to be back in about 20 minutes. Vishal will be talking about Power BI with a bunch of examples. So we will see you back here in about 20 minutes.
All right, thanks.
Thank you.